We're going to discuss a special case for a t-test. Most of us are familiar with t-test for independent samples, which is when you're looking at any t-test, it's looking at comparisons between two values. In the case of independent samples t-test, you're looking at unrelated or independent groups. When you do a dependent samples t-test, to the contrary, you're looking at related groups. So, for example, any pre and post type of test, where, say in healthcare, you take a baseline, then perform some sort of intervention, and then you want to do a post test to see what the effect was of the intervention. Since these are the same subjects before and after, they are related. Thus, they are a dependent t-test is used. And lastly, and it's the one we're going to demo today, which is somewhat more rare, is the t-test for single samples. And now here what we're doing is that we're looking at one group of data compared to a known value or a reference value. Okay, so for example, let's say that if we're looking at nurse practitioner passing scores for the boards nationally, and we wanted to compare a subgroup of that, let's say DMP students and how they performed on the nurse practitioner boards, uh, we would be comparing that one group with this known, you know, uh, uh, passing uh, value that would be comparing it to. Another example or another way of thinking about it is when you have a group that you're comparing to a gold standard in healthcare, for example. If you have a certain threshold that you want to achieve and you want to see whether or not your research data has achieved that gold standard or that threshold, this is the type of t-test that you would use. And we call it it's either known as a single sample t-test or a one sample t-test. One sample because you're just using one group as opposed to comparison between two groups. Here you are doing two comparisons, but it's just one group compared to this reference value. Okay, or this gold standard. SPSS refers to that actually as a test value, and we're going to see in a second here how that works. But in our example, we have this is a small sample, just 12 cases, but let's say that it was a lot more. We'll pretend, and we are looking at systolic blood pressures that we achieved on a group of subjects that underwent a special diet over a period of X time. And now what we want to do is we want to compare it to a reference value. Again, remember, we're not comparing it to another group, but to a sort of a known standard or a gold standard. Here, we're going to say that we wanted our people to be at 130 millimeters of mercury for systolic pressure measurement or less. Okay, so we want to see, does the mean of this group here, the mean blood pressure of this group, is it statistically different from our standard of 130? Have we achieved some sort of difference? Hopefully, a decrease in our case. Okay, and so we're going to test that, and we do it similarly like with other t-tests. We go under Analyze, Compare Means. It's the first choice that we have here, one sample t-test. Okay, we only have one variable here in our small data set, so we're just going to move it over. That's our test variable, and here's that test value I mentioned. And we decided that our test value is 130. See, this is markedly different than any other t-test, right? Because we actually have this known reference or gold standard that we are testing our group to. Okay, under options, we want to leave that at 95% confidence interval. We hit OK, and we get our result, our mean, our standard deviation, and the standard error of the mean. look here under the t-test results. It says one sample test, and underneath you see what that value was, what the test value. So you know exactly what it is that you're testing here against. Our t, as it so happens, was not statistically significant. It's 0.156, which if we use a threshold of the p of 0.5, it does not reach statistically significant. So we can say that, unfortunately, there was really no difference in terms of reaching that threshold that we wanted to of 130, um, given our special diet or our special intervention. Okay, the other thing I want you to note here is that this is actually pretty brief, the results, because you don't have Levine's test. There's no F test here because you're not testing for equality of variances. And the reason for that is because you only have one group. And so they have their own variance, and that's it. You don't need to compare it to the other group because, again, this is special. This is one of the things that sets this test apart.